The instructions I have written down here are a compact way to say what's in the textbook. We're going to analyze a position function. R of t is equal to t squared, 1 over t squared. We can find the velocity by differentiating. We can find the speed using the velocity. And we can find the acceleration. I'd like for you to pause the video and find all three of these things. Since the components of our position function were power functions, we're going to differentiate using the power rule to get velocity and acceleration. Our original function was t squared, 1 over t squared. The derivatives of those components are going to be 2t and negative 2 over t cubed. That's our velocity vector. Our acceleration vector is going to be the second derivative, 2, 6 over t to the fourth. Speed is the magnitude of the velocity vector, and so we have the square root of 4t squared plus 4 over t to the sixth. That's the first set of stuff that we were asked for in this exercise. Next up, we're asked to sketch the path of the particle. That means draw the curve r of t. And we were also asked to draw v of 1, the velocity vector at t equals 1, and a at 1. I'd like for you to pause the video and do that now. Well, I did most of what I asked you to do. Since r of t is t squared 1 over t squared, the graph of r of t really resembles the reciprocal function. We can also see that as t increases, x increases, and therefore this direction of this is down and to the right. If you didn't remember those arrows, please throw them in now because that's required when you have a curve described by a vector function. Since v of t is equal to 2t minus 2 over t cubed, v of 1 is 2 negative 2. A of t is 2, 6 over t to the fourth, and so a of 1 is 2, 6. Now we were not asked to draw r of 1, but I want to show you where it exists. It's a vector in standard position, and given the definition of r of 1 is here the vector 1, 1. The velocity and acceleration vectors are going to be initiated at the point, which is the head at r of 1. In other words, their tail is on the curve. The velocity vector is 2, negative 2. With its tail at 1, 1, the vector 2, negative 2 is going to be about right there. So that's the velocity vector at t equals 1. The acceleration vector at r of 1 is 2, 6. And so from, again, that point 1, 1, we're going to go 2 units over and 6 units up. And that gives us a of 1. The velocity vector is the direction that the curve is going in at the moment. The acceleration vector gives us an idea of where that curve is going to end up. And in this case, the velocity vector is pointing kind of down, the acceleration vector is pointing kind of up, and we can see that the curve is bending so that it's becoming less downwardly, if that makes any sense.